This video is the C2 section of the January 2013 core paper. The first question is on the fertilizer section of C2. It describes information about various different chemicals, some of which are fertilizers, some of which aren't. The first question is how many atoms are there in a formula for ammonium phosphate? It gives you the formula here. So if I write the formula of this out, the N doesn't have a number here, so that indicates that there's one nitrogen atom and then it's 4 hydrogen atoms. Now all of this bit is in brackets and it's got a 3 there, so the total inside the bracket is 5 atoms, times it by 3 is 15 atoms, plus 1 phosphorus atom, plus 4 oxygen atoms, so 15 plus 1 plus 4 is equal to 20 atoms for the first one. The next question is which of the solid chemicals would be used by Sarah to neutralise acid soils. So if it's going to neutralise an acid, the chemical we're looking for has to be a base. Now if you look at the list, ammonia can act as a base, but that isn't a solid chemical. So it's ruled out because it's a gas, so it can't be ammonia. Ammonium phosphate and potassium sulfate are both examples of salts that are used as fertilizers. So it's the carbonate that is what you need to use. So bases can either be metal oxides, so for example calcium oxide, or metal hydroxide, like calcium hydroxide would be an example of a base, or any metal carbonate will act in the same way and will neutralise an acid or a base. So it's metal carbonate is the answer. The next question is potassium sulfate is a fertiliser. It is important that it is soluble in water. Explain why. And the reason for this is really straightforward. Soluble means it can dissolve, and so it has to be dissolved in order for it to be absorbed by the plant. If it's not soluble, it won't be absorbed through the roots, and so the plant can't take in the fertiliser. He wants to make potassium sulfate, and he decides to neutralise an acid with potassium hydroxide. Which acid should he use? This question is about naming of salts, and the salt that we're using is trying to make is potassium sulfate. Now, the sulfate bit is the part that gives you the hint as to which acid. A sulfate is always made from sulfuric acid, or H2SO4, okay, sulfuric acid. If it was a nitrate, it would be nitric acid, and if it was a chloride, it would be hydrochloric acid. Next question is describe the experimental method used to make potassium sulfate solution. So this question is in simple terms, what is the name of the experimental method that we use to make a fertilizer? And the method is what we call a titration. Now a titration is a very accurate chemical process where we very, very carefully add an acid to an alkali using a burette, which is a tall, thin glass tube with measurements down the side. And it allows us to very, very slowly add the acid drop-wise to the alkali, and this means that we can work out precisely when it's been neutralised. So the second mark for this is that we add the alkali to the acid until it is just neutralised. We are looking for what we call the end point of the reaction. So we add an alkali to our acid until it's just been neutralised. Some scientists want farmers all over the world to use more fertiliser. Others want them to use less. Evaluate the uses of fertiliser in terms of which view will have the best outcome for the majority of people. So this question really is, in simple terms, what are the advantages and disadvantages of fertilisers? So when you see the evaluate command word, that's what you need to think. What's the advantages, what are the disadvantages? So the disadvantage of fertilisers is that they can cause eutrophication. That's the major disadvantage. And eutrophication is where fertilizers run off into the water supply then increase the level of algal bloom in the water system. The algal bloom then goes on to die, and as the decaying matter sits at the bottom of the river, in what we call the detritus layer, bacteria will build up and will decompose the algae. The problem with so much algae being decomposed by bacteria is the bacteria needs to undergo respiration, and the respiration removes the oxygen from the water, and that consequently kills fish. So eutrophication is the major disadvantage, or that it causes the death of aquatic life. I'm just going to put a little fish just to remind you of that. So it kills fish. And why fertilizers are good things, that's our negative point. Our positive for fertilizers is it increases the yield of our crops dramatically. And so it benefits a large number of people in terms of providing the food. Please don't put that it helps them to grow faster or better. That's too vague. It increases the yield of the crops. Okay, so the next question is about equilibrium reversible reactions, and you will have studied in this section in C2E the Haber process. Now this question isn't about the Haber process, but it doesn't actually matter because it gives you all the information you need in the question. So it gives you all the information about with a catalyst and without, what happens as I increase the temperature, and what happens as I increase the pressure. And you should take time to look carefully at these tables and really think about what they're telling you. And it's telling you the percentage yield that's being made during this reaction for our required product, which is hydrogen. So the question is, what conclusions can Phil make about the effect of using a catalyst? Well, if you look at the two tables, with a catalyst and without a catalyst, you'll see that at the same temperature, at the same pressure, they are in fact identical. So that tells us one simple thing about a catalyst, which is that it has no effect whatsoever on the yield that's being produced. What a catalyst does do is it speeds up the rate of the reaction, and so, but it does this in both directions of the reaction, and so the overall effect is, whilst it may be faster, the yield doesn't change. Changing the temperature, as you increase the temperature, the percentage yield will increase. So as you change the temperature, as you increase the temperature, the percentage yield increases. And if you change the pressure, again, just reading off the table, the percentage yield will decrease. As you increase the pressure, the yield will decrease. It will get less, and you can see that just by looking. If I increase the pressure going this way, I can see the yield reducing. And again, for the temperature one, I can see as I increase the temperature going down 300 to 500 to 700, I can see my yield increasing. 3 marks. Explain 2 other factors that reduce the cost of making hydrogen. The use of the catalyst reduces the amount of energy that's required to initiate the reaction, and so saves money because not so much energy is spent on providing the energy to make the reaction work. So using a catalyst makes it go faster. That's 1 mark. In equilibrium reactions, we recycle any unreacted raw materials so that they're not wasted. That would be 1 mark. This is done on an automated system, so that reduces the costs of wages, so we save money there. It's also a continuous process as opposed to a batch process, and because it's easier to automate, and it reduces down the time, so again that saves money. And also you could reduce heat loss from the reaction by using better insulation, and again that would reduce your energy costs. This question is about the 6-mark question is about the advantages and disadvantages using aluminium versus steel, and this is C2D, which is the making cars section. So in order to get 5 and 6 marks, what you have to do is to evaluate an advantage and a disadvantage for aluminium, and an advantage and a disadvantage for steel, and then you have to finally make a comment as to which one is the most suitable. So the comments you could have put about aluminium from the table is that, and this is a really important one, always look at density on a table, because about 90% of the time there will always be a mark in the mark scheme linked to density, because it's the one that the fewest number of people understand. So low density is usually a good thing, because it makes it lightweight, and that means it's got a higher fuel economy, which is good because you're going to save money. So always look for a low density. That's a good thing. So that's a good point about aluminium. It also doesn't corrode. That's a major point. It's malleable, so that it can be bent into the correct shape. It's not very strong compared to steel. It's got a lower hardness. It's got a lower strength. Now this means that if it was in a crash, then it was less likely to protect you. The hardness is again lower than steel, so it's more likely to get scratched. Comments for steel you could have would be that it's strong, so there's less likely to be damage in a car crash. You could have that it is malleable again, so that it can be bent into the correct shape. It corrodes slowly, so it won't last as long, so you'd have to spend money on rust protection. It's hard, so that it won't scratch easily, but it has a high density, so that means it'll have a poor fuel economy. Generally speaking, you've got to think about the context of the question. This is about a steel railway carriage or an aluminium railway carriage, and so we're not interested at all in what the electrical conductivity or the heat conductivity or the magnetic properties of these metals are for this particular use. So often people will talk about electrical conductivity and heat conductivity when they don't need to, and in this question you don't get any marks for it whatsoever. Ultimately, you could decide either of the metals to be the right one to use, but all you have to do is make sure you clearly state your answer and support it with a reason. Okay, this question is about electrolysis of brine. It's the final section. So we're looking for it to balance the symbol equation for this reaction, which you should have put a 2 in front of the sodium chloride, a 2 in front of the water, and a 2 in front of the sodium hydroxide. 1 mark. This reaction involves both oxidation and reduction. Explain which reaction corresponds to each. So the rule for this is you've got to remember the acronym OIL-RIG. Now, OIL-RIG stands for oxidation is loss of electrons, and reduction is gain of electrons. So all you have to do is if you'd have wrote that, you'd have got a mark, but you identify them in each of these reactions, which one's which. So if you look here, this is gaining 2 electrons because it's got a plus next to it. So this one is reduction, and this one has got a minus, it's losing electrons, so this one is oxidation. 2 marks. The last question is about plate tectonics. First question is a quite straightforward question, is about theories as opposed to a specific bit of science knowledge. Why it took 50 years for the theory to be accepted. And the main reason for this is the idea that a theory is not accepted until it has new evidence that will support and back up the theory. So it's not accepted until there is new evidence to provide support. The evidence in this case was seafloor spreading was discovered, and we investigated the bottom of the ocean floor. You could have also had that it's just a theory and that there is no evidence 50 years ago, or there was no definitive proof. And the other thing you could have had a mark for is that now we have the technology to observe the movements and of the plates, and that wasn't available 50 years ago. This last question is on the collision when 2 tectonic plates collide, and it asks about the collision between a continental and oceanic plate. Now, what happens when these 2 plates collide is an oceanic plate is more dense than a continental plate, and if something's more dense, that causes it to sink, so it passes underneath the continental plate, and what happens here is what we call subduction. Now, because the oceanic plate is being forced down, it will melt due to heat from the core, and as it melts, the magma will rise, and this is why you get a volcano arc along these type of plate boundaries. So the 2 marks for this is that the oceanic plate moves underneath the continental plate because it is more dense, and the second mark is that the plate will then melt and if you do the diagram and label it, that's also 4 marks.